Okay, let's go through checkpoint 14. Which of the following statement is true? Okay, the answer will be B, a beam of white light, 7 different colors directed at a vessel of cold gas, right? So meaning that all the gas atoms will be at the lowest energy level, can only cause the formation of absorption line spectrum. So absorption line spectrum is dark discrete lines on a colored background. So what is causing the dark discrete lines, right? Very simple. First, imagine I got a gas atom with different energy level, right? So this is your lowest energy level, then this the second level, third level. So I got 2 photons. So the first photon has energy of 5 eV. As you pass through the gas, it is going to excite this gas atom to the second level because it's exactly the same, right? 5 eV. So when you excite the gas atom, this 5 eV is going to get absorbed, meaning that it will form like a dark discrete lines right here. So there will be a dark line right here. Okay, so in turn, of course, the electron, right, is going to de-excite eventually because you cannot live at higher energy level, right? So during the de-excitation, the photon will be emitted in all random direction, meaning that the photon, right, is not going to fill up the dark discrete line, meaning that the dark discrete line will still be a dark discrete line. Okay, let's just say I have another photon of 4 eV, for example. So there's a gas atom at negative 10 eV. So as you absorb, let's just say you absorb 4 eV, you're going to live on the staircase because negative 10 plus 4 is about negative 6 eV. So you're not allowed to live on the staircase. You're only allowed to live on the the first level, second level, and third level, right? So nothing is going to happen, meaning that the gas atom, right, is not going to get excited. So the 4 eV is just going to pass through straight and form the colored background. Because of course there's a diffraction grating right here. Let's just say there's a diffraction grating, right, to so-called disperse your color into 7 different colors. Okay, so the answer will be B. Okay, what about A, C, and D? So A, C, you notice that they say that a beam of electron directed at a vessel of cold gas can cause the formation of either an absorption or emission line spectrum. Okay, it's not going to cause an absorption line spectrum because why? Because to form an absorption line spectrum, you must have a white light. So for A, and C, right, there's no white light involved. There's only electron involved. So means you cannot form the absorption line spectrum. Of course, you might be wondering, can it actually form the emission line spectrum? Okay, let's analyze this together. So for example, let's take a look at this diagram right here that I draw. Okay, so imagine I have an electron, incident electron, right, and this is a gas. So this gas atom will be at the lowest state, lowest energy state. So when the electron hit or passes through the gas, it's going to excite the electron, let's just say from the first level to the second level. Then eventually, right, it's going to de-excite. So during the de-excitation process, there will be an emission of photon, right? And this photon might be able to form like a color background. I mean color discrete lines. But the probability is not high because remember when you emit a photon from high energy level to low energy level, right, the photon might not be directed towards the screen. Sometimes can be directed, maybe let's just say to this part, sometimes maybe up, sometimes maybe down, for example. So over time, the formation of your emission line spectrum might not be so prominent. So I will say A is wrong. Okay, C is also wrong. Okay, D, a beam of electron directed at a vessel of cold gas can only cause the formation of emission line spectrum, is also wrong. Because the transition, right, from higher energy level to lower energy level, of course it will emit a photon. So you might think, emit a photon, so there will be color discrete lines on the dark background, but the emission is random. So means over time, right, you will never see your emission line spectrum. So that's why for checkpoint 14, I will say the best option will be B.